Much.
Thank you.
Okay, everyone. So I'm Eric Jones, go by AJ. Today's session is going to be over a swan dive into filtered indexes and statistics. I'm basically the principal technology manager here at Perpetual Technologies here in Indianapolis. So there's my website information and some little logos there. Basically, my background is both in application development. I mainly do .NET now, and then basically everything SQL Server. So that's kind of the blah, blah, blah about why you should be listening to me and stuff. I will be speaking at PASS this year, so if you're going to PASS, I'd be more than happy to talk to you up there. We'll have a booth up there and everything, so I'll be around basically the whole time. Okay, so I thought today we would talk a little bit about not the kind of bland thing about filtered indexes and statistics, but kind of go more in depth into what they're actually doing behind the scenes. So this is a primer, as well as kind of showing you some gotchas that you may run into along the course of kind of implementing this stuff. So what you may want to do is kind of cautiously approach this topic and kind of do some testing on your own, because it really is kind of a new technology, but it's not implemented entirely how you would typically think it would be. Okay, so filtered indexes have basically been around since SQL Server 2008. They're kind of awesome for performance tuning, especially for those folks who are actually using it to do very large data sets and such. You kind of hit a limit when you're doing those very large systems of being able to performance tune stuff, and this is kind of another notch in your tool belt. So what it provides for us is in things like improved query performance, because instead of doing an index over the whole of a table, you're actually doing it on a subset of data, and we'll kind of look at how things fall in and out of that subset. It reduces storage costs. So your filtered index, of course, if you're not building up the index tree based upon a whole table, but rather a small subset, it's obviously going to cost you less in terms of storage. And also, Microsoft likes to say that it's reduced maintenance costs, because the indexes are not that large, so it doesn't take that much to rebuild one as opposed to a full index. And that's kind of a little BS on their end, because in practice, when you get down into it, you'll actually see that the indexes themselves will only be performant to the point where you can tune them properly. So there's a lot of can't do's that go along with this. And those include that you can't do clustered indexes, right? So, and that's kind of an obvious one, because what you would normally try to do in terms of doing a subset of data is on a non-clustered index, because the clustered indexes, of course, are stored with the data, and so it makes it impossible for you to do a subset of those. There's no indexes that are able to be applied to views. So those of you that have index views, you won't be able to do partial indexes on your views, because it sort of defeats the purpose of the views. You can't do CLR types, so that's kind of another bummer, in the fact that since they rule out CLR types, that means that basically there's no spatial data ones, and there's no XML sets. and that also means that, sorry, but no user-defined types either. It also applies to no computed columns. So once you go through Microsoft's white papers and you look at all the have-nots that are included with the filtered indexes and statistics, you can basically boil it down to the fact that, if it's not a regular SQL Server type, then it's basically a no-go. Okay, so this is really for you to go about and actually use on your regular column types and get it taken care of. Okay, so how you do this is basically pretty simple. All they've done is they've created an extension to the create index technique, right? So you're writing just basically a create index statement just like you normally would, except at the end of it you're putting on a where clause. And as soon as you put on that where clause, when the index is built, then that is then defined as a filtered index. It's basically as simple as that. And then to modify that index, what you would want to do is you would want to just go and use the create index with the drop existing clause. And I've got a couple of those in my sample scripts that I'll provide to you for the session. Okay. So then the question becomes really, when we should go about using filtered indexes. And for that, it's kind of a judgment call. You can go by what Microsoft says, but I would take it with a grain of salt as far as what you should actually do. So let me just open up a piece here. Okay. Okay, I'm sorry. Did the audio went away? Okay, so is the audio back again?
Yeah, the audio's fine now. We got this corrected.
Okay.
Yeah, it's good.
Okay. Okay, so was that on my side or?
There was some echoing going on. I don't think that I had not muted at first, and then I think it was cutting in and out. So.
Okie dokie.
And if you can't see anything on your screen, it is actually showing the slides. So if you can just log out and log back in to GoToWebinar, that should clear up your issue.
Okay. So a little technical stuff. Okay. So then basically when you should use this is basically when a column only has basically a very small percentage of relevant data, and that doesn't necessarily mean that it's small as far as a fixed number, but small in terms of a percentage of the overall data that's in the column itself. Okay, and you kind of have to make a judgment call as to what constitutes small enough to warrant a filtered index. And sometimes your tables are so large that even a higher percentage value like 40 or even 50% of, say, a table may garner you some improvement in your overall query cost. So the other time is when you basically can't or you don't want to use an index view. The cool thing about the way that Microsoft has implemented this is that you can actually have index views and you can have filtered indexes on the same data, basically the same tables, and the query engine will then compute and decide based on what it knows about the environment to determine whether or not it would use your index view, or underneath the view if it would actually use the filtered index on the table. So that's kind of cool how they've worked that into it. And then, of course, one of the important things is when things like index space becomes a big problem for you. So in these very large systems, sometimes you're needing to create new indexes to improve performance, but of course, with anything, the thing that's hindering you a lot of the times is space available to do that. Okay, and then also when online index operations are important to you. So they've actually taken some forethought into this and thought it through and said, okay, well, we're going to implement, filtered indexes. We need to implement them so that you can do all the online index operations that you normally could with any other index. Okay. So let's go ahead and let's switch over and let's see some stuff. Let me just scroll up here. So what we've got here basically is that I'm just using the AdventureWorks database, and then I'm creating a couple tables in here. I'm just saying statistics on so that we can actually view some statistics to see what's happening, and I have the execution plan tab turned on so that we can view that. So basically what we're going to do is we're going to look at an instance where we have our sales territory table in here from the AdventureWorks data set, and then I'm going to create another table, and this table is going to be called the AJ sales table in the sales schema. And basically all I'm going to have is just a real simple table to where I have a territory ID, a sales amount, and a payment type. Okay, and then the payment type is the territory ID will correspond to these territory IDs here. The payment type will be basically an integer that corresponds to 0 for cash, 1 for check, 2 for card. So nothing really important either way. So we get to the point where we're going to input some data. So what I want to do is I want to kind of create an extreme case where we have very few of some sales and then a lot of some other ones. So the scripts will actually load up the table for you, and we'll load one sale from Great Britain. We'll load a couple thousand from Australia with checks, and then we'll go ahead and we'll load 1 million or so from the USA with some cards. And in here, all I'm doing is I'm assigning dollar amounts to the sales based on the integer that we're looping over and stuff. So nothing too fancy here. So basically when we get done, you should have a table that's in here that basically relatively looks like some sort of data table that you would end up with in your production environment. I've even provided you a script to that I won't run now, but basically jumbles up the USA territory IDs so that they look a little bit more random like this, rather than just having this subset of USA only. So we've got this, and we can see that we have our one sale here, a couple thousand sales here, and then these ones are kind of blown out from there. So if we look at our extreme set, which would be our filter, our one that we would possibly be looking at to do a filtered index on, and we look at this one where the territory ID equals 10, we can go and we can execute this, and we can look at the execution plan, and we can see that with no indexes on the table right, it's just basically going to do a table scan, and it's going to go and do like a bajillion logical reads across the table in order to assemble the data that we're looking for. So now basically all we're going to do is we're going to go ahead and we're going to throw basically a couple non-cluster indexes on there. And these aren't doing anything fancy. We're just putting a clustered index over the payment type and a clustered index that covers over and includes a couple columns that we have in there and goes over the territory ID. So nothing fancy. These are just regular non-clustered indexes. And now if we go ahead and we look at what we're getting back, we can see that now the logical reads are basically down to 3, which is much better, and we check the execution plan. And we can see down here from the object type down at the bottom that it's actually using our index territory normal, which is our normal non-clustered index. Okay. So now let's go ahead and what we want to do is we want to jump in, we want to go ahead and create a clustered index on here. So the clustered index, I'm going to call it territory filtered, okay, and I'm basically going and covering the same columns. So this statement is basically the very same statement as what I have up here, except that I put a where clause on it, okay. So I've put the where clause on this, and then I've added the with drop existing here. So if your index is already existing, you would need to use this clause. But since we don't have this out here yet, I'm not going to do that. Okay. So now I have my filtered index placed on the table, and so I have a filtered index and a non-filtered index on the same column. And now if I go ahead and I run my query, what I'm going to come up with is now I can see that in my relatively small table, right? I've dropped the reads down to 2, which is not a drastic improvement. In my execution plan, I can basically see that I'm actually using the filtered index now. Now where this will come into play a lot more is that as these table sizes go up, these reads will become basically more important. So as your data expands, of course, that number will basically expand. So if we don't have one of these, but we have maybe a couple million interspersed with a table that has a couple 100 million entries, this becomes very important in terms of performance. Okay, so now we can see that this actually has some benefit to it in that we are getting filtered and then also a lower number of reads. So it's actually working, and it's actually picking out the actual index. Now, if we try to do something a little outside the space of this value, you can see that we do the exact same thing, but we use an in clause. We can see from the execution plan that the reads are going up because we've added this additional value, but the more important thing is that down here it's back to using our territory normal, okay? And that would be the same thing if this was a ranged value as well. So if this was read and the value was an integer and we were reading greater than, less than, okay, it would go and it would basically, if it falls out of the range of the where clause, then that would mean that it would fall basically out of the range of using the filtered index. So when you set these up, when you set this non-clustered index up, and you actually go and set up this where clause, you have to be really careful about how you're going to set that up and have that applied. And it may be one of those things where you have to constantly go back and look at it to determine if the filtered index is really maintaining its job or not, or whether you need to update this where clause to include a couple more values in it. Okay? And this where clause can be basically as simple or complex as what you want it. The only real problem that you ever run into is if you're trying to set it up with like an implicit type of conversion where this is a character and you're trying to set it to, and it doesn't like that. So what you have to do is you have to make sure that in your where clause you have it set up as basically the same data type. Okay, and this would be the same thing if we try to do something sneaky and put an or clause in here, and we'll see if the actual query doesn't react any differently just because I have a filtered index or not. It doesn't try to split this up and parallelize it or anything like that. It's just looking for basically the best index, which is the normal one, since this value falls outside of the territory. Okay. So one of the things that you would normally want to know is what are the gotchas that are involved with this stuff. So if we go back to the slides here, I'll go back over some gotchas. There we go. Okay. Okay, so when we're talking about filtered indexes, we also talk about filtered stats, and the filtered stats are basically pretty much the same concept as filtered indexes. When you apply a a filtered index, obviously you're going to have stats created on top of it, and those stats are obviously going to be a set that's comparable to the data set that you have in the index. Now you can also do just the filtered stats themselves without an accompanying index, just like you can apply stats to any of the columns in the system itself. And this is Microsoft usually comes off as saying this is used to combat the bad query plan estimation. So and the logic is exactly the same. You're just expanding on the create statistics theme. So it's create statistics, stats name, on table name, columns, and a where clause. Okay, so nothing different. As soon as you add the where clause to either a create index or create statistics set, then you basically have created a filter set of that data. Okay, so next slide. Okay, so then we get into the period of the gotchas. Okay, and this is where there's not a lot of detail from Microsoft's end on, like, okay, so I implement indexes and I implement statistics. So what do I need to know as far as gotchas so that I'm not just throwing these out willy-nilly and expecting them to work, and they don't. Okay, so most of the gotchas that you have basically deal with performance over time. And so in order to delve into that, you need to know a little bit about indexes. So basically the way that the indexes are updated as far as the statistics are concerned is that they're updated automatically when changes meet a threshold. So it's not necessary that the indexes are totally rebuilt or anything, but the statistics on top of them are basically recalculated. Okay, and actually the statistics aren't basically thrown out as soon as they meet these thresholds. Actually, for a while now, they just basically go and they're marked as invalidated. And then the next time that somebody comes along and requests something that requires that particular statistic, then those statistics are then rebuilt. Okay, so and since I think that it's since 2005 version. Prior to 2005, those changes, that threshold was basically based upon rows changing, and now it's based upon column data, which actually is sometimes much better because your statistics, of course, are applied at the column level. But it can also cause a little bit of mischief, especially in this realm of filtered sets. So that threshold is basically approximately 20%. So that's what you'll find out there if you look at any of the performance tuning blogs or anything like that, is that this threshold that causes SQL Server to say, hey, I've got to invalidate these stats, is basically set at about 20%. So if you go and you do the math on this, is that if you say have a 10 million row table, right, and then your filtered index is only, say, 10,000 rows of that tables, okay, well, that's basically 2 million rows is the 20% that needs to change before the stats are actually say, hey, I'm invalidated. Let me go ahead and rebuild the stats for this particular column, right? And it doesn't take into account the what filters may be applied to the indexes. So that kind of sucks in the fact that you may update your actual filtered index, your stats on that filtered index. You could actually go through and update that like 200 times over, right? And the stats would not meet that threshold yet, and therefore the stats wouldn't get updated. So in our case of where we had the filtered index of, say, the territory ID equal 10, if we suddenly blew up with U.S. orders and everything, and we changed a bunch of them around to be 10 now, and instead of having 1, we had 10,000. The stats on that thing may go and point to it only for that filtered index only being one value within the set, right? So it's a very bad thing. So what we generally want to do with some of this is to look at the what we can do to make sure that we can have properly indexed stats on both the indexes and the stats part of it, so that we get the correct values, or at least close to the correct values when the query engine is trying to estimate what it's trying to do with the job that we've given it. Okay, so in order to do that, basically what you do is you basically use the NORECOMPUTE. You kind of micromanage those stats and those indexes. So with the indexes, you would use the switch for statistics underscore NORECOMPUTE, and for stats, you would use the switch for NORECOMPUTE. So what that'll do is that'll turn off the automagical stuff that happens in the background, and then you're able to pick basically a much smaller range than that, maybe 10%, maybe less than that, for the stats to be rebuilt on. Okay, and then you would go and you would run your own routines to update those stats, and when you do, when you're running those against a filtered index, my little all caps thing down here as the main point is to ensure that you run those full scan, because you're doing a filter index. So the last thing that you want to do is you want to do a sampling when you're already within a subset, and then you're telling stats, hey, can you run a sampling over the table and give me these statistics? So you want to ensure that you run a full scan when you're using the filtered statistics and the filtered indexes. And then let's go ahead and let's switch back and kind of look at some of this stuff in the demo. Okay, so one of the first things that you're going to have to do if you're going to kind of implement this micromanagement scheme is you're going to have to know, hey, how do I go and I find my filtered indexes, and how do I go about finding basically filtered stats? Okay, and how you do that is you just basically use the system views, and you're basically looking at sys indexes, and they have a column in there that is basically called has filter. So when you look at an index or statistics, what you'll see in the management window is that if you bring one of these up in management, you'll see that there's already a filter tab on here, or you can check the has filter and write scripts to handle this. So if you're using scripts to do your maintenance, it's real easy to go and apply this as a where clause filter and then do something different with those particular objects. So if we go here, we can see that what I have here on the indexes is I have ones on filtered index on AJ sales here, and then if I look at, I can also look at the sys stats system table, system view to actually go, and that has the same exact column in it for has filter. So if I go in here and I execute, I can see this, and then I can also use the stats date function to go and figure out when those were basically last updated, right? So I was running my stuff here a little while ago, so you can see it's already updated. Now, one of the things that you'll want to look at is size. So how much size do we actually save in this? And that'll be dependent upon what data is in the index, and also how big or how restrictive of a filter that you've applied to that filtered index. So if we look here on our little small table with like 1,000,000 rows on it, you can see that the index size for our filtered index, since it only basically has one row in it right now, is that you can see that is dramatically smaller than what the the size of the total index over the whole table is. So if you think of that in terms of larger sized indexes, it could actually save you quite a bit. And that means that in reality, even though it's not initially lower in maintenance costs to maintain these things, since you've got to do a little work up front to kind of micromanage this stuff, is that once you get your plans in order, as far as maintenance as in terms of a threshold on server computing resources, it can actually be much smaller for you, because it's obviously a smaller index will allow you to rebuild the things or basically run the stats a little bit quicker. And there's basically other neat things that we can do with this kind of stuff that deal with these filtered indexes and such. We can go and we can create a table. We're just going to create a table called AJ Books, and it's basically going to have an ID and a book name in it. So one of the things that you can't do is you can't go in and say, yeah, I'm going to create this table and I'm going to put a unique non-clustered index on this on book name. Okay. Now what if this particular column, I want it to have the ability to have only unique values in it or otherwise null? Okay. Well, I can't necessarily do that. So if I run this little script, I try to insert unique values, unique null. As soon as I hit the second null, I'm going to be kicked out of here. And it goes and says, oh, duplicate rows. That's no good. Right? Okay. So what we can do is we can actually use the ability to do a filtered index, because remember, it's no different from any other create index column. So that means if I can create a regular unique index, that means I can come in here and create a filtered index for unique. So let me truncate this table because we want to remove our book values. And then all I'm going to do is I'm going to do the exact same statement, right, except I'm putting in this little where clause where book name is not null. And I also have with my drop existing on because I've already got that index in place, right? So I go ahead and I update this. And then now I can execute the same set of statements and everything is good. I can run a select from here. And all of my nulls, but it's given me my unique values here. And if I try to come along and I try to be sneaky and say, let's insert another value here, okay, that's been used before, it's actually now it's hitting the filtered index, and it says, now wait a minute, this is a non-unique value, and kicks that out. So that's one of the cool things that you can do. So what we're going to do now is look at a little bit at the filtered statistics, and this is one that you're going to use probably less often than you do the indexes, and that's because normally if you're doing something like this, you're actually needing indexes put on instead of stats. But it's important to kind of know this. So what we're going to do is we're going to drop all our other stats and indexes so that they don't get in the way of this stuff. So I'm just going to go here. We'll drop all of our little stuff. Let me just refresh this. Okay. So we don't have any statistics or anything on this table. So one of the things is going to be, we're going to go and we're going to do the same kind of query, except we're going to look for payment type, and we're going to look for a sales amount greater than 1,000. So if we do our select statement, okay, so this is sort of a bad execution plan, because if we look at this, it's saying that our estimated number of rows was 1,132, but the actual number of rows was about 900. Okay, so ideally we would want it to estimate closer to the correct amount of rows, because if it gets way out of whack, then it would of course maybe pick something else to do in the query plan that would be destructive to performance. Okay, so now let's go ahead and put some stats on this. So we're going to basically do our create statistics statement, give it a name, put it on the table, We're going to tell it the column names to include in the statistics, and then we're going to put our where clause. So where payment equals 1, sales amount greater than 1,000, just like our query up here. Okay. So we put this up here. So now we've got our payment stats ID statistics in there, and then if we run our query again and look at the execution plan, we see that, well, wait a minute, we created these statistics here, and then it hasn't done anything to my actual number of rows. It still shows the 900 and the 1156, right? And so why don't the values change? Okay, well, one of the reasons for that is that you'll find that if you create statistics after you've run a couple different queries, is that, you know, SQL Server is trying to be helpful. So, oh, I ran this query and I didn't have stats on those columns before, so it's going to go ahead and it's going to assume that I want stats created on that stuff. So it's going to go ahead and create me some stats, and then when I come along and I run the to create the payment stats ID, this doesn't automatically go over and say, hey, I'm going to, you know, redo the statistics and figure out what's going on. Now, if we go in here and we drop the automatic statistics, so I go and I pick these 3, I just drop all 3 automatic ones. I'll go and I'll refresh this view so you know I'm not being sneaky. So now we only have the payment status ID, right? So if we go and we say, you know, run this guy again, and we look again, it still doesn't go and update any of the stuff for us. So basically, what happens is that just because we've dropped those automatic stats and stuff, is that this one isn't going to get updated until we actually refresh the stats again. Okay, so if we check here, you know, this has already built these stats. So it's not these stats that are actually the problem. The problem is that it's created we've created the statistics. It already had some stats in place for it, and then it said, oh, well, okay, well, I'm going to go ahead and just roll with those, okay, until something tells me to invalidate them. So here, what we need to do is we need to update statistics, and we need to run it with a full scan, and then you'll see that once we do this, and then once we run our statement again, and we check our execution plan, now you can see that it's actually, you know, closer to the, well, it's actually the same as the actual amount of rows that we were expecting in the first place, which is very good. That's what we wanted. So you want to be careful in just putting these in place and not doing some checks to ensure that, you know, it's actually running correctly. Okay. So to kind of wrap this up a little bit, since my timer is down to 0, is that the filtered indexes could possibly be very useful in some instances. The statistics, I don't know, not so much a lot of the times, but because most of the times you'll be looking to put an index instead of just stats on there, but it could actually come into play later on, okay? So you need to be selective in their use, and you need to actually test this stuff out, because these are like no substitute for full indexes and statistics. So when you're actually doing your database design, it's not as if you're going to come along and just start out with filtered index in the beginning. You're going to go and assume that your stuff is going to run first off with the regular full indexes and stats, and then this is going to be something in your tool belt that you can bring in later on as your data starts to grow in your set, and then you'll apply those filters. But you'll need to apply them correctly, because you've got to remember the constraint on the where clause will determine whether or not it's actually used within any given query plan. Okay. So with that, we'll go ahead and wrap it up. I see people have questions in the bin, and I'm going to make sure to stick around a little bit to answer those, and then I will go ahead and I will trying to answer all of them in this so that they should be along with the video. If not, then, and I don't get to somebody's stuff, my email is down here at the bottom here, so that's my actual work email. And then if I can answer you via email, I will go ahead and put up a blog post for you at my Programmer's Edge blog site. Make sure the video will be up here later this week for this webcast on Pragmatic Works. And remember to catch me at PASS. I'll be doing some cool stuff showing off master data services in Denali, so it should be pretty sweet. And then I will start to answer some of these questions here. So I'll go through and I'll try and answer. I'll try and go through and answer as many of these as I can here before we leave.
Right, would you like me to...
somebody was asking me about...
Okay, I was just going to ask if you wanted me to ask them out loud, but you can see the question panel.
Yeah, if you can, my screen for the questions is very, very small.
Yeah, you can, sure, no problem. So Jeremy would like to know, how can I get information about the logical reads to appear in the Messages tab of the RHT query results?
Okay, so that's an easy one. So that will be included in the script, right? And you just go and you set that with the set statistics IO on, okay? And then once you set that on for this actual session, anything that you run in the messages area, you'll get that information down here. Okay, so it's very kind of useful stuff.
Oh, okay, perfect. We have another question. What would happen to the performance if there was a query that does not fail within the values mentioned in the filter of the index or stats?
Yeah, so we had shown that a little bit here. So if I go down to a stats one down here where I go and I try to do something outside of the range of stats, this query would not use the filter index that I set up. So if I go and I set up these indexes again, create these indexes, right? Okay, and then I create my filtered index. Not fine, name AJ Sales. Oh, okay, yeah, I deleted it. So okay, so there we go. So if I try to do something in the bounds of the filtered index, right, it'll use the filtered index. If I try to do anything that's even remotely outside of the upper or lower bounds of that filtered index, I would run it and I would see in my execution plan that it's actually running my normal index, my full index. Okay, so it has to be within the bounds of the where clause of the filtered index. So it's important to constrain that, not overly constrain it, because you don't want to have like a lot of filtered indexes on there, because it's the same type of thing as if you put a lot of unnecessary indexes on the table. It increases the amount that the database has to work to keep those indexes updated.
Okay, great. Thank you. We have another question from Jeremy. He just wants you to reiterate, did you say that filtered indexes are only available with SQL Server 2008 and higher?
Yes, that is true.
Okay, great. And we have another question. What is the difference between included and filtered indexes?
Oh, okay. So the included ones are just in the index. It's actually including these types. So this include, I have done this. If you look at the scripts when you download them from my blog site, what you'll see is that here this is just telling it to include these column types. It's not actually a restriction on the size of the index. So it's actually doing it over this whole table, but you're telling it in the index to include these columns along with it. Okay? So you're actually creating an index on territory ID, but saying, hey, most of my queries I'm going to be asking for these things too, so I want you to include those columns. Okay, but if we look down, we created the exact same thing down here with the filtered index. Okay, exact same syntax as what's above, right? Except that we've put a filter on it. So this is going to do the exact same thing, index on territory ID, including these columns, but it's not going to go over the whole table. It's only going to create an index for the values where territory ID is equal to 10.
Okay, great. We have another question from Gary. When is it a good idea to use option recompile?
Oh, you mean an option recompile? Yeah, you would normally not use this. I am just using this to show the I/O, because if I go and I run this several times, it's going to go and cache some of my values and stuff. So this normally isn't like the best option to use. This is only for demonstration.
Okay.
So you want to delete that.
Would the filtered index lock the table when we recreated it?
No, you can, if you have the ability to do an online rebuild of the index, then that can be done online. So you have all the same online features as you do a regular index. It's just that this index is filtered, and usually it's a smaller set. But just like when you're rebuilding a regular index, if you're not doing the online version, you're actually dropping it and recreating it, or you're doing a massive rebuild without the online feature, it's still going to do the same exact locking. So, there's nothing technically fancy about what they've done with these filtered indexes. They've just created the regular indexes, and it just has a filter applied to it. That's the only thing. Actually, it behaves exactly like a regular index in all other aspects.
Okay, great. Stephen would like to know, why would one use filtered indexes versus partitioning the table?
Oh, partitioning the table?
Mm-hmm.
Well, I mean, some people, the partitioning, usually with a partitioning scheme, normally it's a little bit more maintenance that's involved with that. You would get basically the same types of benefits, really, using a good partitioning scheme as what you would do with a filtered index. It's normally just a little bit simpler to go in and implement filtered indexes than it is to implement a full partitioning scheme.
Okay, makes sense. Ramir would like to know, what is the difference between the include versus composite index?
Oh, composite. Well, composite index, you're actually telling it to build the index based upon a set of values. So this, instead of this, it could be something like a composite index of where you're telling it to build an index across the combination of columns, right, which is usually called a composite or a covering index, right? And then it's just telling the index to peg sales amount to go along for the ride. Okay, so normally if you think of it in terms of a clustered index, your clustered index, you could have a territory ID, right, in the index, and then all the other data values, so payment type and also sales amount, are pegged in there next to that particular key in the index. And this is what the key in the index is registered off of. If we go and we say, well, we want a one off of territory and payment type, the index nodes are going to be built based upon the combinations of these two guys, right? That's how you're going to create your nodes in your index. And then you're just telling it, hey, sales amount is going to come along for the ride so that I don't have to go and do some kind of lookup value to go and grab these two in the index and then hop over to find sales amount. This one is just coming along for the ride at index, but it's not used to compute where the basically the nodes end up in the index tree.
Okay. John Lee would like to know, are filtered indexes only updated when a row is added or changed?
Only when a row is updated or changed, that applies to the filtered index. So that's like one of the things. It's almost it's almost like a virtual form of partitioning in that you're going in and you're inserting that row, and then SQL Server says, oh, we've got to do a couple things here. Have we met the threshold to update statistics? No. I've got to update these indexes. So what indexes do I need to update? Well, I've got these two indexes here. I've got a full index and I've got a filtered index. So the full index, of course, I'm going to update that all the time, right? And then the filtered index, I'm checking to say, oh, you've got a where clause on this. Does this value that's being inserted or update meet this where clause? And if so, then it's going to add or subtract a node from the index itself.
Okay. Cam would like to know, I'm hoping I'm going to convey this question. Cam, and if I don't, just please clarify in the question box. Why is size of clustered index and non-clustered on the same column? Why are they different?
Oh, so he's probably asking why are the sizes of these indexes. Let me go down here. Books, values. So we're looking at the size of these indexes here, right?
Right.
So these are actually all non-clustered indexes, right? And the sizes are different because this is my filtered index. So your index size is based upon how wide is the index, or how many columns is the index basically based off of in terms of the nodes that's based off of and what data is going along with it, okay? And then how many of these guys are actually in the index itself. So this one is only over a subset. This is over the whole table, okay? And it would be the same thing if you were looking at non-clustered versus clustered indexes, is that the clustered index, when you do a clustered index, it's always saved with the data. So it basically goes and is pegged on every row that you have within the actual data set on the table.
Okay, great. Alexander would like to know if you could quickly show where on the programmersedge.com website where the scripts are.
Oh, I'll actually have a post up here in probably another half an hour to an hour, specifically for this webcast, where I'll update it with PowerPoints and the scripts that I've used here. So you'll get the exact same thing that I've got, and it'll just have a download link right on the blog post.
Perfect. And if you could please, Don is requesting that you put up your contact slide one more time.
Okay.
And then I think we're done for the day, and thank you so much. That was amazing. I actually learned quite a bit. And if you guys missed any part of it, it has been recorded, and it will be available on our website under past webinars by the end of the week. So thank you so much.
Thanks, everyone.
Thanks.